This LOS is calculate and interpret the standard error of the sample mean. So this LOS is calculate and interpret the standard error of the sample mean. So we'll use an example. So the mean PE for a sample of 100 firms is 15, and the standard deviation of the population is 7. What is the standard error of the sample mean? So when we know the population standard deviation, we use the formula. The standard error of the sample mean equals the standard deviation divided by the square root of n. And n is the number of samples, 100 firms. So it's easy. It's just 7, which is the standard deviation, divided by the square root of 100. So 7 over 10 equals 0.7. So for sample size of n equals 100, the distribution of the sample means has a mean of 15 and a standard deviation of 0.7. The standard deviation of a sample statistic is known as the standard error of the statistic. So we'll just do a quick little practice question to check our understanding. The central limit theorem is best described as stating that the sampling distribution of the sample mean will be approximately normal for large size samples. A, if the population distribution is normal. B, if the population distribution is symmetric. Or C, for populations described by any probability distribution. Okay, this question was pretty easy. The correct answer is C. The central limit theorem, given a population described by any population distribution having a mean U and a finite variance, the sampling distribution of the sample mean, x bar, computed from sample size n from this population will be approximately normal. Okay? So I put any in bold red, and I had any in bold green in the previous LOS. So a pretty easy question. Again, this LOS is calculate and interpret the standard error of the sample mean. So we're just going to finish the LOS with one last practice question. And this question is, the following sample of 10 items is selected from a population. The population variance is unknown. So we've got the 10 numbers, 10, 20, -8, 2, -9, 5, 0, -8, 2, and 3. The standard error of the sample mean is closest to A, 3.4, B, 3.6, or C, 10.8. Okay, this question is not too difficult. It's just very mechanical, but speed is a skill, and skill gets rewarded, and you have to do a lot of calculator keystrokes to get it right. So we know the standard error of the sample mean is the standard deviation of the sample divided by the square root of n. The square root of n is easy. We've got 10 items, so that's just the square root of 10 for the denominator, okay? But we have to calculate the numerator, which is the standard deviation. And so that's just a quick variance calculation. Remember, variance is the sum of x minus x bar squared divided by n minus 1, okay? And n minus 1 is going to be 9 in that case. And so the first thing that you have to do is calculate your x bar, and that's just the average. So that's 10 plus 20 minus 8 plus 2 minus 9 plus 5 plus 0 minus 8 plus 3 plus 21 divided by 10. So we've got our 3.6, okay? Then you've got to do x minus x bar squared. So you can see 10 minus 3.6 squared plus 20 minus 3.6 squared plus -8 minus 3.6 squared. And you can see that's a lot of keystrokes that you need to do to calculate. And then again, you're dividing by 9. You can see there, that's the n minus 1. And we're going to get a variance of 117.6. And then remember, the square root of the variance, standard deviation equals the square root of the variance, is going to be 10.844. So then we're not done yet, because don't forget, you see that's a bit of a red herring there. See, if you've just calculated the standard deviation, no, it's the standard deviation divided by the square root of 10. So 10.844 divided by the square root of 10, you're going to get 3.429, and so the correct answer is A. Not too difficult, just very mechanical, a lot of keystrokes. Speed is a skill. Skill gets rewarded. I recommend that you practice that one on the calculator a couple times. And that's the last slide for this LOS. Thank you.